Hello Room 10. Hopefully you've had a chance to watch my previous video on area and perimeter. We are going to take a next step and try to solve some complex area and perimeter. The only difference here is we are not dealing with regular shapes such as rectangles or squares. We're dealing with irregular shapes such as this hexagon, a six-sided shape. It doesn't look like your regular hexagon, but it is one indeed. The only difference here is we need to find a creative way to turn the shape into one we're more familiar with working with. Excuse me. The importance of it in real life is that this might be a floor plan of a house or a building of some sort, and if we're looking to cover the floor with carpet or flooring of some sort, we need to figure out the area of the space that needs to be covered. The outside, perhaps this is a border of a yard, and we need to build a fence around it, or figure out how much space is the distance around the figure. Perimeter would help us. Now to solve a perimeter problem for this complex shape, we don't need to do anything different than we did on the simple problems. Perimeter is just the distance around, and we need to figure out we need to add all the different units and lengths of each side together, and we'll be able to find our perimeter. So starting here at the bottom, we have 10 meters plus 2 meters. Coming up here, plus 8 meters plus 4 plus 2, and finally 6. I can find some real easy pairings to work with. Here's 10. 2 and 8 make 10 again, so I'm up to 20. 4 and 6 make 10 again. I'm up to 30. And then if I add that last two, I will have a perimeter of 32 meters. You didn't need to know a whole lot different than skills than what you had for basic perimeter problems. It's area where things get a little trickier. What we need to do here is we need to actually try to simplify things and make this shape into two shapes that are a little more familiar to us. In this case, we can extend this line right here straight down, and we now have two different rectangles. Let's call this rectangle B, and let's call this rectangle C. If I can find the area of each of those individual rectangles and then add the two areas together, I should have the area of the entire shape. So if we're going to say the area is equal to the area of B plus the area of C, I think we're actually pretty prepared to do that. Area of B is just length times width. In this case, if you look at B, the longest side is this one over here, has a length of 6 meters. The shortest side is 2 meters. It's labeled right here for us. We know because this is a rectangle, this short part right here will also be 2 meters. We multiply those together and we get 12 meters squared. Area C, on the other hand, this is a little bit misleading because this 10 meters is actually from point to point. So the longest side is actually from here to here, and we see that it's labeled as 8 meters. We're going to take that 8 meters. The short side is pretty obvious. It's the same as this one right here. That's 2 meters. Multiply them together, and we get 16 meters squared. Now, area of B plus area of C would be the area of the entire shape. All we need to do is add 12 and 16. That's 28 meters, and our units are squared. For any complex area problems, all you need to do is divide up your shape into simple rectangles or squares, and then use your basic length times width formula. Hope this helps.